Hello, everyone. Welcome to the 29th edition of our InfoGest Viva webinar. My name is Raphaela Mantovani, and I would like to introduce my colleague Marina Eichhorn, who will conduct this webinar with me. This event is organized by a team of postdocs from Teagasc Food Research Centre in Ireland. The webinar series aims to share the latest findings in digestion with presentations from recently graduated PhDs, postdocs, and early career researchers. The presentation in a pre-recorded video will be followed by a question and answer session with the speaker. So I invite you to use the Q&A button at the bottom of your screen. Our speaker today is Rebecca Sempio with her project about closing the fiber gap in refined cereal product quality and health. Rebecca conducted her PhD research in food science at University College Cork, School of Food Science and Human Nutrition, in collaboration with APC Microbiome Restore Ireland. Her research expertise is in food technology, focusing on product design, fiber inclusion, cereal products, techno-functionality, sensory analysis, and in vitro digestion of fiber enriched products. Additionally, Rebecca has joined Teagasc as a postdoc and will be part of our team hosting the next editions of the InfoGest webinars. Now, let's hear.
Good afternoon, everyone. Thank you for the introduction and for the great opportunity to talk to you today about my PhD thesis. I would like to present to you the work that I did in UCC, University College Cork, in collaboration with the Professor Elke Arendt and under part of the project of the APC Microbiome Restore Ireland entitled Closing the Fiber Gap in Refined Cereal Product Quality and Health. So just to have a little bit of context on the fiber intake recommended, the daily adult intake suggested is around 25-35 grams per day, but the European actual intake is way lower, is around 16-24 grams per day. This is generating what is called in literature fiber gap, where only 1 person out of 10 is actually meeting the fiber intake criteria. The cause to this is the consumer preference for refined cereal products due to their characteristic listed below that prefer sweeter aroma, softer crumb, golden color, compared to what the whole grain products offer that are nutritionally superior but still rejected by the public. This is the product characteristic are generating what is referred as consumer resistance. So the first part of my research was a literature review to analyze the state of art of the fiber studies in literature at the moment. So considerable researchers are focusing on implementing individual fibers in the different products, but little is known on the synergetic effect of combining multiple fiber ingredients. Another topic that is currently studied is the use of upcycle ingredients. That still is not able to pinpoint the effects that these ingredients will have on the food matrix. So the aim of this research was to identify a mixture of functional fiber ingredients compatible with the refined wheat matrices that I'm referring to, evaluating their performance in dough and products, the health benefit, and consumer acceptability. So just to see a little bit the study design involved in this research that is common for the following 3 chapters, I was using the response surface methodology, RSM. The RSM is a statistical tool that is able to randomize different variables. So I use a face-centered central composite design, and the objective was to study different variables such as the different fiber ingredients and see the effect on product structure and texture. So in this way, I was able to study both the individual addition of the fiber ingredients, but as well the effect ones that we're using in a mixture. And as you can see in the slide, the different variables again were the different fiber ingredients, and then the different response specific for each product were analyzed. So these are just all the recipes that I had to prepare and analyze for pasta, bread, and cake. To go a little bit more in depth of the study design, a fiber ingredients library was chosen to have a mix of different fiber with different characteristics, such as soluble, non-soluble, viscous, non-viscous, fermentable, non-fermentable. This was done in collaboration with the nutritional team in APC to select the right fiber for the human intervention trial. And the different fiber were then applied to the different food matrices, such as pasta, bread, and cake, based on preliminary studies. After this, the products were characterized based on techno-functional analysis, nutritional analysis, and sensorial analysis. To get into the core of my research, in the following slide, we can see the measured result collected from the different recipes. The data were imported in the RSM software that optimized a final recipe with the following characteristics, such as implement the tensile strength, decrease the cooking loss, and decrease the stickiness, all values that are very important for a pasta product as reported in literature. So the software responds with a suggestion for a recipe with a replacement of part of the semolina with 10% cellulose, 14% resistant starch, and 2% pectin. And these are the products that I ended up compare through the study. So a semolina control pasta made by 100% semolina, and a fiber-enriched pasta where the semolina was replaced at a level of 26% with the fiber ingredients. So first set of analysis was then run on the dough. As we can see from the different graph, the measured results was an implementation of the kinetics of gluten aggregation and a reduction of the general viscosity. Then, as follow, I focus on the final product, the pasta. No significant difference was found in the optimal cooking time, neither in the swelling index or cooking loss. A significant difference was found in the reduction of the thickness, and then there was a visible difference in the color between the control product and the fiber-enriched product, but this difference decreased once that the product was cooked. Last but not least, the set of nutritional analysis was running. As we can see, highlighted in the table, there's the fiber concentration that in the fiber-enriched product is more than double compared to the control pasta. This result can be also linked to the release of reducing sugar over time that is reported in the graph on the right side of the slide. These data were collected using the simulation of digestion in vitro with the dialysis tubes. And as we can see, over a digestion time of 300 minutes, the fiber-enriched pasta considerably decrease and significantly decrease the release of reducing sugar over time. So to conclude this first research chapter, I was able to achieve a white pasta high in fiber. The network was affected by the fiber mixture, but it was made more resistant, and also decrease of reducing sugar was achieved over time. This recipe was used as base for a human intervention trial in collaboration with APC Microbiome Restore. Another important take-home message are the portion size that the fiber enrichment will bring to the daily fiber intake. As we can see, the control pasta will cover only 20% of the recommended daily intake of fiber, whereas the fiber-enriched product will cover 47%. So to move to the next chapter, I focus on the cake. Again, on the left of the slide, we can see all the measured results for the RSM. And on the right side, we can see the desirable characteristics that were input in the software, again, based on literature, has reduced bag loss, increased specific volume, and reduced hardness that led to an optimized recipe with around 7.5% replacement with cellulose, almost 15% replacement with resistant starch, 0.5% replacement with arabinoxylan, 7.5% replacement with beta-glucan, and almost 8% replacement with pectin, leading to an overall replacement of 38% of the flour with the fiber mixture. And these are the two final products that I was focusing on, control cake and fiber-enriched cake. So again, the first set of analysis was in this case a butter analysis, where an increase in viscosity can be appreciated in both graphs, resulting in a denser butter and more structured matrix. Then I focus on the final product, and no significant difference was found in the bake loss, neither volume or slice area, as well as crumb hardness and stay rate. But an increased number of cells and all was appreciated, as well as a decreased area of cells and diameter of these cells. I also ran some shelf life that highlighted how prolonged the shelf life in the fiber-enriched product can be. Then, once again, the nutritional analysis, the core of this whole research, highlighted that the fiber-enriched product can be classified as a source of fiber. On the right side, we can only see the simulated digestion, the in vitro simulated digestion, and even if we have the same concentration of sugar and butter through these all product, we can notice a decrease in the release of reducing sugar over time. So to conclude also this chapter, I designed a weight cake source of fiber with comparable techno-functional properties to the control product, and once again the decrease in release of reducing sugar was achieved. The recipe was designed for the human intervention trial, and in this case the control cake will cover 3% of the recommended daily intake for fiber, whereas the fiber-enriched product will cover 27%. The last research chapter that I want to talk about today is about the bread product. That is a very important staple food in our diet. Once again, on the left, we have the results that was imported in the RSM. In this case, increase in specific volume and number of cells, as well as a decrease in hardness was required for the optimized recipe. And the recipe consists in a replacement of 11% of flour with cellulose, 40% with resistant starch, and 2% with arabinoxyland, obtaining a final replacement of 53% of flour with the fiber ingredients. And once again, these are the two products that I was focusing on: the baker's control flour bread, and then the fiber-enriched bread. In this case, for the SEM image, it's very interesting to see where the blue arrow is pointing, that is an intact cellulose fiber. First set of analysis, again, was run on the dough. In this case, what we can appreciate is, first of all, an increase of the kinetics of gluten aggregation, as well as a decrease in the network strength. Then with the Rio fermentometer, I was able to study the fermentation pathway, and we can see that due to the replacement of easy digestible sugar because of the subtraction of fiber and implementation of fiber increase, there's a decrease in the CO2 production. And then the Mixolab was run analyzing the different techno-functional aspects of the bread pasting dough characteristic, and we can see that there's a decrease in the gluten development and a decrease in the retrogradation, starch retrogradation. So to move to the final result of the bread, due to the higher replacement of fiber in this product, there was a significant decrease in bake loss at specific volume, a significant increase in hardness, and a decrease in the stale rate. Also for the bread, the shelf life was run, and even if the mold, as we can see in the graph marked by the lighter green, was showing up after 3 days, the kinetics in the fiber-enriched bread was considerably slower down due to the fiber enrichment. Finally, the nutritional analysis, as once again highlighted in the table, in the fiber-enriched product, the fiber concentration is more than double compared to the control. And once again, on the right side of the slide, we can appreciate the stimulation of digestion and a significant reduce into the release of reducing sugar over the digestion time. So to conclude this pack as well, I was able to achieve a white bread high in fiber. There wasn't comparable physical properties with the control bread, but in this case, I remember that 53% of the flour was replaced with the fiber ingredients, and there's a decrease, the decrease of the reducing sugar over time was achieved. In this case, the control and a consumption of the control portion would cover 7% of the recommended daily intake, whereas the fiber-rich consumption bread will cover 15%. So to summarize and conclude what we saw today, pasta, cake, and bread were enriched with purified dietary fiber and results in white products high in fiber. And the daily consumption of the fiber-enriched pasta and the fiber-enriched bread will cover the 63% of the dietary fiber recommended daily intake, that along with a correct diet full of other fiber like vegetables and beans, etc., will achieve a good health status. The results collected from the human intervention trial with the consumption of this product we hope that will set a new target for the scientific community, and the public health impact that we expect from this research is closing the fiber gap in the population and improve the population health. So I would like to thank, first of all, my supervisor, Elke Arendt, and all the team in UCC. Thank you for listening to me today, and yeah, I'm happy to take any question.
Thank you so much for your presentation, Rebecca. It was a great talk. So let's start the Q&A session. Do we have any question in our Q&A box? Not yet. So I invite you to write your question in our Q&A box. And maybe I can start with my question because I was doing some notes on during the video. And maybe we can start with a general one. So I was very curious about the choice of your formulation. So you choose pasta, bread, and cake as matrices, but they differ a lot in the structure and formulation itself. So did you select your formulations or your recipes or your products based more on the relevance for closing the fiber gap in commonly consumed foods, or maybe how well fiber can be incorporated from the processing perspective? So what was the main reason to take these products?
So thank you so much for your question, and it is a great first one. I would say this research, as I was saying at the beginning of the video, was in collaboration with the APC Microbiome Restore Ireland, and it was the base to develop a human intervention study that will have provide a full diet to the people taking part on this human intervention trial. So first of all, we needed very important staple foods that are in everyday diet. The human intervention trial was run here in Ireland, and for this reason, we developed a bread product because it's part of the daily diet, and pasta as well. To talk about the cake, it was chosen to supplement something sweet because it needs to be representative of a normal diet, and even if it's not nutritional, really valid, people will always look for something sweet every so often. So to implement that, I designed the cake. But other products were also designed that are not part of these presentations, such as scones, crackers, and lots of others. So yes, this is the reason.
Okay, perfect. Thank you so much, Rebecca. Oh, perfect. We have some questions in our Q&A box. Perfect. Maybe I will jump to the one which also appears on YouTube, and this is one from Nick. Does it matter that cellulose is not digestible, and does it still count on daily fiber intake? What do you think?
So yes, for the dietary fiber, we are following the Codex Alimentarius definition that is actually including cellulose as dietary fiber that we can consume in our food. Cellulose will be naturally present in all the vegetables because it's basically the backbones of your cell structure. And even if it's not being digested during your digestion process, it still have all the important characteristics that fiber can have, such as implementing the filling sensation and as well implementing the mobility of your transit during the digestion.
Perfect, thank you. So if we are talking about the fibers right now, we have another question about the source of the fiber. So Alison is asking, what was the source of the added fiber? Did you purify them yourselves? If yes, how pure they were? And then she added also another one. Are there cost implications for added fiber?
So another great question, of course, and the fiber that were selected were commercial available fiber. So I didn't do any practical work on the fiber itself. So size speaking, purification speaking, everything was as it was commercially available on the shelf. And the reason why this was necessary was, first of all, that all this food need to be produced for the human intervention trial. And it was actually a huge part of food production. I took took part myself in the food production, so it was a huge part of the study, and it needed to be done as quickly as possible as well for logistic reasons. And the last part of the question, sorry, was, if you can remind it to me. The cost, of course, it has a higher cost adding purified fibers, but it's something that for the human intervention trial was vital to figure it out, how these products will have performed on the human health.
Perfect. So I guess we will jump to another fiber question, and then we are going to the digestion. We have 3 more on digestion afterwards. So the last question on fiber, this is from Sophia Schneider. So how have you obtained the different fiber fractions? The control bread seems to be darker compared to the fiber-enriched bread. And did this happen due to different baking conditions? What do you think?
So again, the fiber were commercially available, and the control bread, the control bread seems darker. You mean the top? So I guess that the baking condition, of course, were kept the same to be able to fully compare the products at the end of the production. The reason why, in my opinion, for my research, the top of the control bread was darker is due to an increase in the Maillard reaction. So basically, in the fiber-rich product, the ready available sugar that would react in the Maillard reaction were replaced by the fibers that weren't able to obtain that full reaction. This is the reason why the control crust is darker compared to the fiber one.
Perfect, thank you. So now let's jump to the digestion part. And we have one wonderful question from Rocio Morales. She's curious about the methodology you was using for the digestion, especially also about the release of reduced sugar. Maybe you can just briefly describe what did you do for these, please?
Yeah, absolutely. So for this part of the analysis, I based the analysis on a paper that Brennan and Tudorica wrote in 2008. And it's a simulation of in vitro digestion specified design for fiber-rich product using dialysis tubes. So basically, of course, similar to the InfoGest, using the enzymes, the different steps of gastro and intestinal phase were simulated, and as well to simulate the proper peristalsis that is happening during the intestinal phase. The samples were basically agitated every 15 minutes and sample was taken every 30 minutes and at the end analyzed with DNS with the spectrophotometer.
Okay, perfect, thank you. And then also regarding the digestion, Rocio is curious about, so what do you think? The decrease of release of reduced sugar is linked to the decrease of starch in pasta, bread and cake? And, do you think there might be some interactions between starch and dietary fiber that may prevent digestion?
I would say that it's definitely like a mix of the two parts. So reducing part of the ready available sugar, of course, is reducing the glycemic peak that we will obtain, but as well, the fiber are known to slow down, and basically, especially whenever pectin was used, these fiber almost create a gelatin matrix that I think would prevent the enzyme to penetrate the food matrix and therefore slow down the digestion process.
Perfect. And then maybe the last one, I guess, for today. This is a perfect link between, so the question comes from Eva Hernandez, from our former colleague. Could you mention whether the overall project objective includes assessing any correlation between the in vitro data and the results from the human intervention trial in cases where both evaluated the same response?
I would love to be able to give you this answer, but at the moment, I guess that the analyzing of the human intervention trial is still happening. They don't have the final data yet, but I can send a follow-up as soon as the paper will be published, or you can also find the results eventually looking for Professor Jens Walter group on Google Scholar. And yeah, be updated with this amazing research, because I think that when we will have this final data, it could actually change the science behind dietary fiber in a way. Thank you so much.
Perfect. Thank you also from our side. We have a small announcement. I will share our slides and then we will finish our webinar.
Thank you so much, Rebecca, for the presentation. Thank you, Marina, for presenting the webinar with me. So I'd like to announce our next speaker. We will be back on 4th of March with Sue Dong presentation. I also like to mention that we are looking for speakers. So we have an open call for expressions of interest. And if you are interested in presenting your work, please email your name, affiliation, and suggested title of talk to infogest.viva@gmail.com. And a last reminder about the Food Digestion Conference that's coming soon. I just wanted to let you know that the submission deadline for abstracts was extended, and now the new deadline for sending abstracts is 28th of February 2026. And thank you all for participating, and see you in March. Bye.
Thank you. Bye.
Thank you.